Have you ever wondered why two identical watches, placed at the foot of a mountain and the top, end up showing different times after several years? Is this a sign that time flows at different rates depending on where you are? In energy filament theory, this isn't some mysterious or unexplainable phenomenon. It's actually the result of the tension field subtly altering the rhythm or beat of time itself. The idea is that the flow of time is closely linked to the structure and tension of the energy sea in which we exist. Earlier, we introduced the idea that the universe is like a gigantic mattress made of varying degrees of tension. Massive objects like stars, planets, and black holes pressed down on this mattress, creating regions where the tension is higher, similar to areas that are tighter or more compressed. Think of the entire universe as a series of layers of tension, each one having a slightly different rhythm or vibration within the energy sea. What physicists call equipotential surfaces in the conventional sense becomes the layers of tension in this model. Within each of these layers, all objects share the same rhythm, as if they are all synchronized to the same microscopic beat that governs the energy seas in that region. In energy filament theory, time is defined as the counting of repeating actions within the energy sea. Whether we're looking at the vibrations of atoms or the ticking of a clock, both are following the same microscopic rhythm. The more tightly compressed the energy sea is, the more difficult it becomes for those vibrations to occur. This tightening of the energy sea results in a slower overall rhythm, and hence time seems to move more slowly in these areas. On the other hand, if the tension is lower, the internal vibrations are less constrained, and the rhythm speeds up, causing time to appear to pass more quickly. Thus, on the surface of a planet, the tension slope near the base of a mountain is tighter than at the top. The atoms, clocks, and even biological processes like heartbeats work at a slightly slower rhythm near the mountain's base, due to the increased tension in the energy sea. At the top of the mountain, where the tension is less, the same physical processes occur with less resistance from the surrounding energy seas. As a result, the clock at the top will run just a tiny bit faster over the course of a year, compared to the clock at the bottom. This phenomenon is what we observe as gravitational time dilation. Clocks near a massive object, located in the valley of the tension field, tick slower. Meanwhile, clocks that are further away from the gravitational well, placed in areas where the tension is less, tick faster. However, it's important to note that this is not time changing itself, but rather how the tension field at different points in space dictates the rhythm or pace of time in that area. You can think of it like this: equipotential surfaces equals the same layer of tension. The higher the tension in a region, the slower the internal rhythm, and therefore time passes more slowly. By understanding this concept, the idea that time moves faster or slower in different places no longer feels mysterious or supernatural. It becomes a natural and understandable consequence of the energy sea's tension landscape. Time, as we experience it, is a product of the way tension is distributed throughout the universe. The local tension map determines how objects and even lights are affected by the slopes of tension in their surroundings. The way time changes based on your position is simply the result of the path you take along these tension gradients. Once you grasp this framework, the concepts of gravitational time dilation and space-time curvature can be understood as two ways of describing the same thing: the physical manifestation of the energy sea's tension. What may appear to be mysterious phenomena are, in reality, just the natural outcomes of how the universe's energy sea is structured. Follow, share it on New Physics, Clear Universe.